back. Today we're going to be talking about slope and y-intercept. So let's go ahead and get started with that by taking a look at a few key terms. The first key term that we have here is rate of change. Rate of change is a rate that describes how one quantity changes in relation to another quantity. The other key term that we have there is slope, and slope represents the rate of change in a linear function. And remember, linear functions make lines. Now let's take a look at some more key terms. So talking more about slope, we understand that slope measures the steepness of a line on a coordinate plane. We find slope, also known as m, by the change in y value divided by the change in x value, or the vertical change over the horizontal change. There's also a y-intercept. The y-intercept is the point where the linear function crosses the y-axis and the x value is 0. Now let's take a look at this in practice with example A. Here we are at example A, and they've given us a table that talks about the number of hours and the total amount earned. We have to answer some questions about the independent dependent variable, identify the y-intercept, and answer a couple questions. So let's start with the independent variable. The independent variable is the number of hours because we know that is x. The dependent variable is the total amount of money earned. So those are our x and y. Now our y-intercept is going to be where this line will cross the y-axis and will also be where our x is 0. In this case, we can see that in our table, we've got 0 at the number of hours, and the total amount of money earned in that case is also $0. So 0 and 0. So our y-intercept at this point, or where they're going to cross the y-axis, is going to be 0. Now it says, suppose you have a job walking your neighbor's dog. You get paid a rate of $6.50 per hour. How does the total amount of you earn relate to the total number of hours you work? So if we take a look at our table and we're going to figure out what's happening here. So between 0 and 1, we can see that's adding 1. From 1 to 2, that's adding 1. From 2 to 3, that's adding 1. And from 3 to 4, that's adding 1. So we can see that our x is going up 1 every time. On our y's, we can see that we're adding 650 to get from 0 to 650. 650 plus 650 is going to give us 13. 13 plus to 1950 is going to be 650. And to get to $26 is again going to be 650. So we can see that it's going up 1 on our x and it's going up 650 on our y. So in order to show this as a rate of change, our rate of change is going to be 650 over 1. Or because we're talking about money here, $6.50 over 1 hour. So now we need to answer the question. Suppose you have a job walking your neighbor's dog. You get paid a rate of $6.50 per hour. How does the total amount you earn relate to the total number of hours worked? So in this case, we can say the amount you earned increased $6.50 every 1 hour that we worked. Now let's take a look at example B. So here in example B, we've got a graph that talks about the total cost and the number of games. We've got an independent dependent variable, y-intercept that we have to identify, questions, and slope that we need to answer. So let's start with finding our independent variable. Remember, our independent variable is going to be our x, and luckily for our graph, it's going to be labeled on the x-axis. So that's going to be the number of games. Then we need to look at our dependent variable. Again, that's going to be the y-axis. So in this case, we're going to be talking about total cost. Now we need to identify the y-intercept. So again, where is that line crossing our y-axis? And we can see that it's crossing right here at 0, 0. So our y-intercept in this case is going to be 0. That's going to be where it crosses the y-intercept. Now we need to figure out the cost per game is displayed in the graph. How does the number of games affect the total cost? Well, in order to answer that question, we need to figure out the slope. So we need to figure out how much the line is going up for each number of games. So here we've got the number of games of 1 has gone up to 2. Then we go to 2 games, it's gone up to 4. 3 games, it's gone up to 6. 4 games, it's gone up to 8. And 5 games, it's gone all the way up to 10. So that we could see that every time we're going up 1 or up 2 and then over 1. So again, for the next one, we're going up 1, 2. So that's going to be our 2 there. Oh, we got to write a 2. And we're going over 1. So again, we're going to be going up 2. And we're going to be going over 1. We're going to be going up 2. And we're going to be going over 1. Did I need to do it for every single one of those once I saw the pattern? No, I did not, but it was very helpful for me. So I know that it's going to be going up 2 over 1. So my slope will be up 2 over 1. And you can reduce that because 2 divided by 1 is going to be 2. So our slope in this case is going to be 2. So let's answer the question. And the answer to the question is, each game increases the total cost by $2. Now let's take a look at example C. Here we are at example C, and it's talking more about numbers of hours we worked and total amount earned. So again, we're going to identify the independent, dependent variable, y-intercept, answer a couple questions, and figure out our rate of change. So our independent variable is going to be the number of hours. That's going to be our x. The independent variable or dependent variable is going to be the total amount earned. Now we need to figure out our y-intercept, but our y-intercept is a little different this time. We can see that if we're looking at our graph or at our table, that the number of hours we work is 0, but the total amount that we've earned is $10, which is pretty nice, a job where we get $10 without having worked. And it says, now suppose you have a job walking your neighbor's dog, and he pays you a $10 bonus before you start. So perhaps there's not a lot of dog walkers in the area, so he needs to pay you a bonus in order to get your business because there may not be a lot of available people. So our y-intercept, since they're paying you a $10 bonus before you even start, is going to be 10 because that's when our x is going to be 0. So our x is 0. Our y-intercept is 10. So now we need to figure out our rate of change. And he's still paying us $6.50 every hour. So if we're taking a look here, we're still going up our +1 every single time. So +1 from 3 to 4. And we're still going up our +6.50 every time. So our rate of change has not changed. So our rate of change is still $6.50 per 1 hour. But what has changed is how it's going to affect the amount that we relate to the number of hours we earn. So in this case, you earn $6.50 every 1 hour you work plus a $10 bonus. So we have to make sure that we include that $10 bonus in how our total amount earned is getting paid. Now it's not $10 bonus every hour, it's just plus $10 one time. And that's very, very important because we're not adding $10 plus $6.50 every hour. That would be getting $16.50 every hour. It's just a one-time pay of $10 plus $6.50 every time there forward. Now let's take a look at example D. So here in example D, we're going to be again talking about our independent dependent variable. We've got ourselves a graph, we've got a y-intercept, question answer, and our slope. So let's start with our independent variable. We know that that's going to be the number of days because it is our x-axis. Our dependent variable is our y-axis, so that's going to be our turnip price. Now we need to figure out our y-intercept. So where is our line crossing that y-axis? We can see that it's right here at 0.8 on our graph, so our y-intercept is going to be 0.8. Then we need to figure out the cost of the turnips as displayed in the graph. How does the number of days affect the total cost? So we need to figure out how much it's costing us every day to hold on to these turnips. So if we're going to take a look here, we can see that after 1 day it's down to 6, 2 days it's down to 4, 3 days it's down to 2, and 2 days it's down to 0. Now notice that our line is connecting. It could be that the reason that this is connected is that the price is falling a few cents every single minute, every single second, every single hour, our price is going down. You can see that our graph is going down. So we're going to connect these because the price is falling throughout the day. So now that we have that information, we need to figure out what our slope is going to be. So again, we've got to figure out how far we're moving down and over. So if we go from 8 to 6, we can see that we're going down 1, down 2, and then we're going over 1. So that's a +1 because we're going over 1 to the right. Then we need to do the same thing for the next one. We're going down 1, down 2, so -2, but we're going over 1 to the right, so that's +1. Now we're going down 1, going down 2, so again -2, but we're going over 1 to the right, so +1. So we can see that our slope here is that we are going down 2 and over 1. So we're going to represent that down 2 as a negative thing, so negative slope. So we've got -2 over +1 because it's still going to the right 1. The number of days is still adding 1. It's going from 1 day to 2 day to 3 day. So that one is still being a positive number. But we can see the price is going down, so that's going to be a -2. So how does this affect us? This affects us because the cost of the turnip decreases $2 every 1 day. That brings us to the end of this set of notes, brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.